So here is this 2x2 RGB LED matrix logic, and what I'm using here is the Teensy and then these two are identical, but not using this one. This is a multiplexer, demultiplexer, and what I'm trying to do here is, since each RGB LED has three inputs, using this red wire here is what's actually powering the LED. These yellow wires, they're basically bits. I don't even need 4 of them at this moment, but you know, basically half byte driving. The yellow wires are going into the multiplexer, and then what's coming out is, made it as RGB, red, green, black, but I don't have a blue wire. So each one of the basically the bits, the yellow wires, correspond to one pin on the multiplexer, and then that is going through and setting the power of this red wire to the LED, and then the grounds on the LED are this white wires coming in back into an input here. And when the LED is off, both the multiplexer is not set to the LED anode of whatever color it's supposed to be, and as well as the white wire is set to on, so it can't complete, the LED can't complete its circuit. And all I'm doing for this bit is taking just putting a delay in the for loops of it cycling through. So these two LEDs on the left here, they are on the left side. They're the first 3 here, and then each one has its own white wire, and then the right side is the next 3 over here, and they share the same 2 white wires going back, where the one in the back has the one on the left and the ones in the front have the one on the right. And while it's just kind of flipping through it now, when I set it to be without any delay, which I'll do right now, so it's compiling at the moment. Okay, just reset it. So without any delay, they basically are all trying to set their LEDs all at once, and in an ideal situation, like theoretically, it should be white. It's a little green. In person, it's much more green than it's making out to seem here. But so instead, basically the goal here is, I would have needed to be able to drive these LEDs individual, to select any color I wanted and to have them on and off at the same time. I'd need each one of the LEDs to have its own, like each color have to have its own cathode. So each LED, if I were to drive it directly from the Teensy would have needed to have 6 inputs, or 6 pins basically, to drive one color LED direct. But by using the multiplexer by using the multiplexer, I was able to drive 4 color LEDs with 1, 2, 3, 4, 5, 6, 7 pins to drive four color LEDs, I would have needed to use 24 pins if I had to go directly. So there you go. Oh, if you wanted to sneak peek at the code here, I know it's a video and it's kind of lame to, but that's what the code looks like. That's actually cycling through here. So kind of interesting thing I did here is I have this, where is it, set LED multiplexer, and it goes through, and the LED columns are just integers, and then the 4 pins that the multiplexer uses are listed here, and I go in and set so if I set the LED multiplexer, whichever pin is getting driven by the red wire to actually power the LED, I want it to be on. So it goes and gets the integer in here, and then it just goes through the bytes and sets each pin in the array. So basically this, whichever integer it's on here, it corresponds to what LED these pins would have, and theoretically this one can go up to 16 on this type of multiplexer.